John. I'd like to welcome Eamonn Williams, who's the Facilities Manager at Aviva, joined in 2009, so just 6 months prior to the opening, and background in manufacturing and healthcare facilities, and responsible for implementing the ISO 50001 energy management system here at the Aviva. Focuses on benchmarking within the sports stadium environment around the UK and Europe. Over to you.
Thank you very much. Is that microphone working?
Yeah.
Or hands-free?
Sure, I think it is. Yeah, should be there. Oh.
Hello. 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 Okay, if I could welcome Aiden, my colleague, to the dais as well. Welcome everybody to Aviva Stadium, myself and Aiden's workplace. And I definitely must go and get a job in Kingspan if they give all their employees a Tesla. I look forward to that. As I said, what I'd like to do is to give you a bit of an introduction as to Aviva Stadium and its genesis and its changes in the last couple of years, and go on to our experience of implementing ISO 50001, which Aiden will cover, and back on to me on benchmarking as well. So Aviva Stadium is actually the oldest rugby ground in the world, continually running rugby ground in the world. 1872 is when the first people were here with athletics and other stuff. It used to have 28,000 standing on terraces, and there was obvious health and safety concerns. Those of you that remember the England game back then, and there was no opportunities for earning extra revenue in a conference and events type of situation like we have here today, and it was below modern standards for international sport, so something had to be done. And you'll probably remember the whole Bertie Bowl issue about sports stadia in Dublin, and we ended up with a decision to stay here because city centre was better and we were well served by the rail line, the Dart line, and so we got a stadium of 50,000, cost 410 million, 200 million from the government, or 191 million from the government, and the balance equally shared by the FAI and the IRFU. Thanks, Aiden. So the stadium that we have now is obviously a much different animal to what we had back in 2009 and before, with much better fan facilities, and technology has moved on so fast that we are running to stand still. In fact, with Wi-Fi demands and stuff like that, facilities where you can buy your drink from an app on your phone, order up different camera angles from your tablet and stuff like that. That's the direction we're looking at. We have much better commercial opportunities, better facilities for the players, the coaches, and the media. We can run concerts properly, and it's a proper international stadium. In fact, in the Euro 2020 bid, which we just successfully got, it turns out Aviva Stadium came third in Europe as far as they actually scored all the stadia, and Aviva Stadium came third after Wembley and the Amsterdam Arena. So we're very proud that we got that achievement. Thanks, Aiden. So we have partners for conferences and events, which is a contracted partner with a 20-year agreement and marriage with us, if you like. But the actual management of the stadium itself is the org chart is there, and we're on the left-hand side there. There's myself and Aiden and 7 trade staffs, mechanical, electrical, controls, and building. So it's a small team that run the stadium. So straight to energy, when we opened in May in 2010, that annualized figure there gives us a 19 gigawatt energy consumption, which is obviously massive, and it's between gas and electricity. We generate with diesel generators for match days to give us independence from the grid. We do keep in sync with the grid, but we don't rely on them. We treat them as 1/5 of our supply source, so we're completely independent in that regard, and we're capitalising on the opportunities of DSUs and WPDRS and that kind of thing because we have our own generation. But we had a massive consumption, which you would probably expect in a new venue that opens up. Everything is to hand the stadium over to us with everything running, literally everything running, and we had to work out how and how much we could turn off. From 2011, 2012, 2013, we were on our energy quest, we'll say, and we achieved savings deferred expense savings of over €1 million just in those 3 years if you were to draw a straight line across the top from 2010, and even more savings in 2014, even when you normalise for activity level, because you got to normalise. So one of the early exercises that I'm assuming that everybody here is familiar with, the ISO 50001 process. It's not that different to it's not extremely different to the 14001 process, and one has to identify where one is using one's power. And without adequate metering when we took over the stadium, this was our best estimate based on tabulated data, and it gave us, that's what we expected to be our energy consumption across gas and electricity. Okay. So this electrical breakdown, electrical only, for August just gone, is 85 to 90% accurate. Because we've got an excellent metering and management process in place, we are getting excellent transparency on it. So we match it month by month. We report to management month to month on these SEUs, and if there's a change in any one particular one, we pick it up from a management point of view, we pick it up on a monthly basis, so there's no surprises, and which is what energy management is all about. No surprises, you know where your expenses are, and so thanks, Aiden. So with the metering package, which is Inistic, give them a plug-in for that, which is an excellent package. It's very versatile. We're still on a learning curve with them, so sometimes patience is required, but it's doing its job for us. We've broken down our SEUs, our significant energy users, into groups, and each of those groups reports instantaneously and by the week and by the month. We just plug that data, we just take it down in Excel and plug it into an 80-20 Pareto matrix. That goes into the managers, the management monthly report, and if it changes, then they see it straight away. So the yellow there is how far we got to go down in order to get to 80% plus of our loads. So the first 5 are 80% of our loads. Probably, I should explain the third one, pitch Grolux. They are 450 kilowatts of lighting, which gives electrically generated photosynthesis onto the grass. That's running nearly 22 hours a day for 6 months of the year, because the stadium is so large that it throws shadow on the south side of the stadium, which is the side we're at. That shadow means that the grass won't grow without artificial encouragement, and so that's what the pitch Grolux is. It's a massive load. We also have under pitch heating to keep the ground from freezing and to encourage growth. That runs 24/7 in the winter as well, and that's obviously a massive load that we need. And the pitch is sacrosanct. It's like the kitchen, the chef in a restaurant. Whatever the pitch needs, the pitch gets. The fourth one along there is comms, and you might think that's very large for just comms. We've got 90 comms rooms around the stadium, and the comms equipment itself isn't so much the load. The load is actually the air conditioning required to keep the comms under about 23 degrees. Is it 23 or 4?
That's right.
We're trying to tell them that Intel are happy to go up to 28 plus, but the comms guys don't want to take a risk on their equipment. So so that's one of our loads and one of the pressures that's on us. So I'll hand over to Aiden to just discuss the actual implementation process for a moment.
Hello everyone, my name is Aiden Byrne, and I'm the maintenance officer here with the Aviva Stadium. I also co-implemented ISO 50001 with Eamonn. So I just want to go through how we approached our implementation to ISO 50000, and also mention some of the positives that we took away from it and some of the key challenges that we faced. So the first stage for us in implementing was to get buy-in from top management, and as you all know, that's absolutely key. Some organisations tend to give lip service to their implementation, but they don't truly believe in it. We were lucky in the fact that our CEO, Martin Murphy, he could see straight away after 2010's energy consumption that it was absolutely vital to the success of the business that we get a handle on our energy consumption. So me and Eamonn didn't have to sell the idea of 50001 to Martin. He immediately could see the benefits. The next stage which is the identification phase, which Eamonn has kind of touched on, was really where most of our key challenges arose. Because we didn't have any real sub-metering through the original design, we literally had one gas incoming meter and our mains electricity meter. So we really had to use tabulated information, which, you know, isn't exactly the most accurate. Therefore, the SEUs that we identified on the first pie chart may not have necessarily been very accurate, so time was wasted there. Then once we identified, or thought we had identified our SEUs, as you know, you need to identify the relevant variables which affect those. This was and still really is a challenge for us. Obviously the heating system is very, very obvious, and everyone is probably familiar with heating degree days, and obviously the external temperature has an effect. But on some of our other SUs, we're still struggling to pin those down. So constructing relevant and accurate EMPIs is a massive topic for debate, and I would be open to discussing it with anyone afterwards, how they approach constructing their EMPIs. The next line that you can't really see for some reason mentions OFIs. For us, this wasn't really a challenge. We had the technical experience and the ability to look at our technical systems and identify areas of opportunity. We have a list as long as our arm, and we're going to touch on a couple of the key OFIs we implemented and some of the proposed OFIs we plan to implement over the next year. So the planning phase for us during our initial implementation really harped back to the fact we had no sub-metering. So we spent an awful lot of time planning how we were going to implement an electrical and thermal metering system, and obviously a software package then to sit on top of all of that. So a lot of time, money and effort went into that, and I believe had we not have focused on this prior to our certification, we may have been chasing our tails for quite some time, because we would have identified incorrect SEUs, and therefore we wouldn't be putting our time, money and effort into the right areas. Objectives and targets for us weren't really a challenge, because we're in the lucky position where we don't have management dictating exactly how much they want us to achieve each year. And I know that could be quite different to some of you out there, possibly in a manufacturing environment where you are told you need to achieve 10%. So the way we approach it is we look at the OFIs we've planned for the year, we estimate how much of a reduction or impact those OFIs will have, and then we say, okay, that's going to be our target for the year, whether it be 100,000 kilowatt hours, etc. Resources, again, we were in a lucky position that because we had full buy-in and commitment from Martin and top management, that they did allocate the time for myself and Eamonn to allocate to the implementation, because it's very, very time consuming. Financial resources to install 150 electrical meters, 6 thermal heat meters. All of this costs money, and they were willing to invest into the system. And obviously, which is key to any implementation or operation of ISO 50001, is to put together a fit for purpose and well thought out energy action plan. So on the next phase, which is your implementation phase, or take action as I've called it, the number one item, which is actually on the bottom, is the energy action plan. There's no point in putting together a plan if you don't intend on implementing it. It's pretty pointless if you don't follow through. Design and procurement, because we're such a new stadium, we're open 5 years almost, we haven't been in the position where we've had to replace large items of plant like air handling units, fans, etc. So we haven't really had to look at the efficiency of what other plant is out there, but we will in the next 2 to 3 years as maintenance costs go through the roof. OC and M&P, I just shortened that down. It's operational control and maintenance practices from the standard. We already had a planned and routine maintenance system in place even before we knew about ISO 50001. So this kind of really went hand in hand with what we were doing already. So, efficiency of large items of plant was already on the cards. And then training awareness and energy awareness culture within the stadium. Much like any organisation, we had to do a campaign, try and get everyone on board, from catering staff to security. So we held kind of a conference or a talk like we did today, where we had all full-time members of staff, and we just brought it to their attention how you could save energy at home and then how you could bring that into work. So we got a bit of a culture going. And then the final step, which brings it all back together and ties it back in, where you get your buy back in from management. You review your whole system. So review your ENMS, make sure you're conforming to the standard if you are certainly looking for third-party certification. I would say this doesn't necessarily apply to those who are looking to implement it for themselves, who may not have the financial resources to go for third-party certification. You know, there's a lot of documentation requirements there, and that can be quite time-consuming. Do a gap analysis and see where you have any non-conformances, and you know, we put together a register of corrective action and preventative action to address any issues that we found. And then you need to review your energy performance. So as Eamon said, we do that on a monthly basis, so there's no surprises at the end of the year coming up to Christmas where we tell Martin, by the way, yeah, we're way off track, so expect it right. We do this on a monthly basis, so no surprises. So now we're just going to do a quick little talk on some of our preferred OFIs that we've implemented over the last couple of years.
Thanks, Aidan. I'll just discuss the OFIs, the opportunities for improvement, and I think we had about 65 or 75 or something like that. They come in from staff on a dedicated email, or they're our own, or they're something we saw somewhere else. And no matter how small they are or how big they are, they still go into the register. And so just they break down into kind of categories, really. Operational ones. We have about lower 20s, 21, 22 events, pitch events, we'll say, full house, 50,000 people a year. And other than that, the stadium runs as a conference and events. Yet we've got, you might have seen some of the technical sheets that I've sent around there. We've got 69 different kiosks and bars in the different levels around the stadium. And initially the idea was that the staff would turn off coffee machines, fly zappers, tills, that kind of stuff in each chillers or cold rooms in each of these areas. But in my experience, relying on humans to carry out procedures is a challenge and a difficult task. It's far better if you can engineer it out. So we engineered it out in the sense that we got our own crew to just shut the power off in all those areas, and that made a big saving. So it's kind of simple, but you'll find that all your savings are kind of simple, except for a few interesting design changes and stuff, but basically turn it off and realise that it shouldn't be running. So the other thing we did is events like today, sometimes there might be an event here in the Havelock, and there might be 4 other events in corporate boxes on one side of the stadium or the other, where there's small groups of 10 or 15 people. And initially the conference and events people picked a position at random depending on what they wanted, and we got them to say, look, if you only need 4 corporate boxes, don't use that side of the stadium, so we don't have to turn on the domestic hot water to get down there, the air conditioning to get down there, and just concentrate over here. And kind of just common sense. I think hotels probably do that with their rooms if they can, but to us it was new and simple, but it made a big difference on our aircon and our HVAC and stuff like that. Another one was that our event control room has quite a lot of data equipment in it, and it had to be kept on, and that was fed by chillers. There's 12 90 kilowatt chillers on the stand over there, and all the chillers are cycled so that if there's a demand, they have to be running and cycling up and cycling down. And today, with good cool air outside available, we would still have had the chillers running for that. We just turned them off and put in local split air conditioning in the actual event space. Very simple, but just seeing it and realising it. And again, your metering is what will tell you where your consumption is, and then you go and target it.
So one of the main OFIs that I believe had probably the most impact on our energy reduction had to do with how the BMS controlled all the plant and equipment, specifically for HVAC in the stadium. Originally, the designers had it such that it was targeted more for match day. So when you had 50,000 people in the stadium, it ran enough plant to achieve the temperatures that you needed. But we had a look at it after it was handed over to us, and we found that if you wanted to run a conference, much like the conference we're doing today, too much plant ran. A lot of waste, so air handling units, fans. So what we had to do, we had to get Standard Controls, who designed the BMS originally, And they came back in and created a BMS matrix where I had the ability to change exactly what plant came on for each individual space. So that had an absolutely massive impact on our energy consumption, and it was very, very low cost. You know, it was 3 or 4 days programming on site, so you know it paid for itself almost immediately. The next kind of key OFI that we did, it's kind of one of my favourites because it's so simple and so cheap. It was a modification to our hot water system. So because we have 24-hour security on site, you have to provide hot water. You know, it's health and safety. They need to be able to wash their hands around the clock. So middle of the night, Saturdays, Sundays, etc. So we had a massive volume of water which basically heated the entire east stand and south stand purely to heat one little tap down on the ground floor for security. So Eamonn implemented small instantaneous water heaters, couple of €100, and that allowed us to switch off all the boilers on the east stand. So it was such a simple thing, but it saved a massive amount of energy. So that's why I just wanted to mention it. You know, it's not massively over-engineered, but often the most simple options are the best.
And on lighting, what we've done so far has been completely simple as well, just standard passive infrared detectors in various places around the stadium, some control issues with getting people to power them down, and probably a slightly more interesting one, there's a circuit or a route on level 0 down here which isn't open to the public, but buses and trucks and stuff can drive right around the stadium underneath, and there's 80-watt metal halide light fittings in there, and I'm changing them out as a design change to 32-watt PL lamps. It'll also give us the opportunity to perhaps PIR them, but because they'll be instant on, instant off. So it's only a 40 watts per unit saving, but there's 250 fittings there. So it is a simple one to do. Our design isn't an artistic thing there. I think that's with the lettering. I think it's the transition from one version of Excel to the other version of Excel. So I apologise for the peculiar graphics. Next one, Aiden, there, please.
Yeah. One more OFI that I just want to mention. If any of you out there have ever been in a position where your company has breached its SPC, so if you have natural gas, you'll know that you have a supply point capacity. So that's a maximum instantaneous volume of gas at any one given time, and you're allocated that by your supplier. And if you go over that amount, you know, you're heavily penalised, your rates and tariffs go up, and obviously the later you are during the year, like if you breach it in August, it backdates the whole way to the previous October. So there's massive fines associated with that. And we unfortunately breached our SPC several times in the first couple of years, and you know the accountant was kind of jumping up and down wondering what was this SPC fine that he was getting in. So a really simple change that we made had to do with, we implemented a couple of sub gas meters which were tied back to the BMS, and in the BMS I was able to set what our SPC is supposed to be, and then once we reached 90% or 95% of our SPC, the BMS would just switch the boilers off. So essentially, like electricity, we were shedding our load, we were shedding our gas load, because you know you have a thermal inertia in a building. You know, you could switch the boilers off right now, and everyone in this room probably wouldn't notice for half an hour, 45 minutes, and we had a volume of hot water there available, a couple of thousand litres, so no one would ever notice. So in our case, you know, we haven't breached our SPC since, and it was such a simple solution. Again, couple of €100 with standard controls. So I just wanted to throw that out there in case anyone has come across that issue before and they might find that useful. So I'm just going to now move on to some proposed OFIs that we have.
Thanks, Hayden. So the ones that we haven't implemented yet that are sitting on our spreadsheet are as I said earlier, the underpitch heating has, I think it's about 500 kilowatts heating load, running all night and running all day, and also the electrical load at night. So we're looking at a CHP option for that, but the spark spread and implementation costs and life cycle costs are what's under consideration. We did some test metering last winter in order to get our figures, but I'm not happy that I trust them enough. So we have our heat meters in on those loads now, and so in another month or so, when the heating comes on for the underpitch, we'll have more solid data before we go to the board looking for a couple of €100,000. The LCS is the lighting control system. It was and is a computerized control system that we have here. It's a DALI control lighting system, and we'll just put in a load of PIRs in a load of spaces. Again, straightforward stuff, places where we have natural daylight, then we'll tune back the lights to suit the daylight. When we inherited the stadium, electrically the stadium is actually 4 separate systems with each their own transformer, even though they're paralleled, but they are 4. So the lighting control system for this area here has, over to there is one full system, and then the other side is another system. So there wasn't an awful lot of common sense put in when they actually designed this area. So there'll be a lot of changes like that in order to get efficiencies. And the third one that I have on mine here is LED. I've been watching LED for the last couple of years, and I haven't been satisfied that we were there yet with LED. I've been watching what they do in the States, and the issues were colour, temperature, the issues were life of LEDs, the issue were dissipation of heat from LEDs, and the quality of or the life of LEDs. I don't think any of those things were properly satisfied up to now, but I follow Energy Star as a suggestion in the US. They do great work on that. It's a government body, and they have set criteria that LED have to meet, and that's becoming a standard across which all LED manufacturers have to meet. And the stuff I've seen is excellent in the last month over there. I didn't think that CFLs could be challenged by LEDs, but I was given 2 samples that I've brought back of a lamp that you plug out your CFL and you just plug in the LED. You don't have to take out the ballast, you don't have to change any wiring, and it gives you a 50% reduction. The problem is it was only designed in February. I was in a stadium where they've fitted 1,000 of them. That stadium manager is obviously happy to take that chance. I'm not so sure yet, but at least I know that we are ready to go with LEDs, and so it's my intention to go down that direction for sure.
Okay.
Okay. Right. So the other issue that I want to talk about, which applies more to people within the stadium industry, but many of you are in shared industry, so it applies completely. All the things that we discovered here in the stadium, or most of them, we discovered for ourselves. So learning by ourselves, for ourselves, isn't very efficient, and benchmarking needs to be achieved both at stadium level and at significant energy user level. Here's an example of 3 different stadia. Miami Heat in Florida is the red one. We're in the middle there, badly positioned, and a Spain-Portugal stadium, and on the right. So that's their annual consumptions, and that was for 2012, I think. And you can see 3 massive differences in the consumption patterns, which tell you nothing and only serve to confuse you. But what you do is you dig into your SEUs and see where exactly the differences are and whether or not they're explainable or not. Obviously, Miami Heat have a massive refrigeration load, and Portugal, to the Portuguese stadium, have an excellent weather pattern where the amount of actual modification they sit on around 21 degrees. So whereas we're different to that. Yeah, so just some of the big events that we've had here. We've had the Europa League here, which has been one of the biggest events that we've had. The Euro 2020s will be similar, and we're more than ready for it, except that the Euro 2020s will have 4 international games, all visiting teams. So the city will really be buzzing for that. Okay. That was the Navy versus Notre Dame game. 30,000 travelling supporters came to Dublin for that event, which is the biggest mobilisation of sports people that I'm aware of, and that was a big event. That was a big success. We will obviously encourage more of that as the years go by. That was the Heineken Cup final, 2013, I think, and again that was a sellout. So I think that's us, Aiden, is it?
Yep.
If anybody has any questions, thank you very much.
Thank you very much.
Thank you very much.